Alrighty, so we're still on Module 3, Topic 1, Lesson 1B, but now we're going to be looking at Activity 1.3. So this is practicing solving equations. So Activity 1.3 is only one page, and it's 5 problems long. With each problem, we gave you a hint on ways that could make it potentially easier for you to solve these problems. So if you're looking at number 1, yes, you could simply just add or subtract your 12.6 and your 9.6, but why deal with decimals? For this one, your hint is you can multiply all of your terms by 10. So just to verify that you know what I mean, you're not just multiplying the 12.6 and the 9.6, you have to multiply all 4 by 10. All 4 of them need to be multiplied. If you don't multiply all of them, then you're not going to come out with the correct solution. Similarly with number 2, again, a bunch of decimals. All 4 terms have a decimal that you have to work with. In this case, you will need to use 100. You're going to have to multiply by 100. Otherwise, you will not end up with a correct answer. The main reason for that is looking at the first term. You have 2 numbers after the decimal point. If you don't multiply by 100, then these will not move past to give you a whole number. So for number 2, you are going to be working with bigger numbers, but at least you won't have to work with decimals. Number 3, so this one again is dealing with our LCD. So looking here, you have a 2 in your denominator and you have a 4 in your denominator. Your LCD is going to be the 4. 4 goes into 4 once, and then 2 goes into 4 twice. So that'll be able to simplify out. And then for number 4, similarly here you have fractions. So if you're looking, you have an 8, a 2, and a 4. So your LCD for this one is going to be to take out an 8. And remember, the ultimate goal here is you have to get x by itself. And in order to get x by itself, you have to multiply each and every piece by each and every term by the LCD. So that means everything on this side needs to be multiplied by 8. Everything on this side needs to be multiplied by 8. Everything in the parentheses will stay the same. They don't change. And then if you're looking on your slides, you're probably going to notice that 5 was completed for you. And just like previously, I'm going to do 5 for you now, just so you can see why we chose the steps that we chose. I know it's a little bit, for me at least, it's easier to see the work being done than to just have it written there. So hopefully this will come in handy. Just as I had said previously on the other video, you do just need to make sure that you're trying these before asking myself or Mr. Franz for help. Again, if tomorrow before we get going, I will remind you guys how you guys can ask for help so we can tutor you on the slides. Alright, so with that, let's go through number 5. So number 5, if you're looking here, you're going to see that we have 3 and 3 in our denominator. And because of that, I'm going to say that our LCD is 3. So in order to get the 3 out, I need to multiply everything on both sides by 3. So when I do that, I actually have something that looks like 3 times, and then in the parentheses, negative 2, and then 5x plus 4 in parentheses, over 3. Remember, 3 is just 3 over 1. So these 2 3's actually cancel, and you're just left with negative 2, and then in parentheses, 5x plus 4. Now on the other side, there's a little bit more work that you need to do. So we have the negative 3 outside of the parentheses, so we have to multiply that by 3. And then we also have the negative 7 thirds. So when we multiply that, we can multiply it by 3 over 1. So let's go back here. Negative 3 times 3 is negative 9. And then if we look at the negative 7 thirds times 3, it'll be negative 21 over 3. And negative 21 over 3 is negative 7. So now if we were to write that down here to start completing our equation, we have negative 9 times, and remember that parentheses stays the same, 3x plus 2 minus 7. So I don't know about you guys, but I think this looks 100% better and a lot easier to work with, because now I don't have weird fractions. I don't know about, really, I do not want to have to worry about subtracting 7/3 from my end answer. Like, that would be the worst, like the most horrific thing that I had to do. So I'm glad that I was able to get that out. So now I just have to work with whole numbers. So the first thing that I'm going to do is I'm going to do the distributive property. And in this equation, I actually have two sets of parentheses. Now, I would recommend doing one at a time. So the reason that I showed the arrows for both is to show that, yes, you have to do the distributive property for both pieces. So I'm going to go back and I'm going to do one at a time. So I'm going to work with the first parenthesis. So negative 2 times 5x is going to give us negative 10x. And then negative 2 times 4 is going to give us negative 8 equals. And again, I'm just going to keep this second parenthesis, or second distributive property set, the same, just so I don't have any confusion. Now, I need to make sure that I'm using the distributive property, like I said. And what I'm going to do is I'm going to distribute the second set. So I'm going to distribute the negative 9 to both pieces. So we'll leave the negative 10x minus 8 over here, which will be equal to, now negative 9 times 3x is going to give us negative 27x. And then negative 9 times 2 is going to give us negative 18. And then we're going to still have the negative 7 at the end. Or remember, it's subtracting 7 or adding a negative. So now we've simplified our parentheses. So again, just following our orders of operations, we need to combine like terms. Looking at our our left-hand side of the equation, that negative 10 and negative 8, we can't do anything. They both don't have an x, so there's nothing that we can do. So what we are going to do is we're going to just write it simply down. Negative 10x minus 8 equals. Now on this side, the other side of the equation, we have a negative 27x, we have negative 18 and negative 17. Well, negative 18 and negative 17 do not have x or variables, so we can go ahead and simply combine those two. So the negative 27x is going to stay the same. When we combine negative 18 and negative 17, we get negative 25. So now our next step is, I would recommend moving the variable first, just so we can get x in its place. Negative 27 is the one that I'm going to choose to move. You can choose to move the negative 10 if you want, but I feel like the negative 27 is easier, because then it's going to give me a positive variable. So when I do this, I have negative 10x plus 27, and that's going to give me 17x minus 8 equals negative 25. So remember, you remove the 27x from this side, but you removed it from one side, but that negative 25 is still there. So now we just have a two-step equation. So we're still trying to get x by itself. So I'm going to add 8 to both sides. When I do that, I'm going to be left with 17x equals, and negative 25 plus 8 is negative 17. To get x by itself, I'm going to divide by 17 on both sides. And when I do that, x equals negative 1. So that's all you had to do. And I know you're probably like, that's all I had to do? That was like 42.5 steps. I know, but it's what needs to be done. And if you look at it, I think, and of course you're like, well, you're a math teacher, I think that it's pretty simple as long as you know what steps you need to take. I know this first part looks very messy, and it's probably a little mundane, and you probably almost scares you, but once you get past that, and if you know how to use the distributive property correctly, it's a multi-step equation. And I know that you guys have been dealing with equations for a while, so truthfully, I don't think you guys should have any problems. If you do, we're going to be working on this tomorrow. So remember, starting today, we're switching everything around, so you should begin watching these 2 videos tonight, and then starting to work through your slides. And then if you have further questions, you can ask us tomorrow in class.